SwayamPrabha. Digital India. Educated India.
Robotics is a very interesting topic. Today you see almost all the school going kids are fascinated in making a robo, and today there is a lot of advancements which is happening in robo technology. So in this course also, and in reality in computer integrated manufacturing, robos play a very important role. They play an important role in terms of assembly, in terms of painting. So, robos can be used in a painting station, assembly station, cleaning station, as well as material handling. So, robo can be used for spot welding, robo can be used for painting, robo can be used for seamless painting, robo can be used for inspection also today. So, robo plays a very important role when we talk about computer integrated manufacturing. So, here the content of this lecture is going to be robot anatomy and related attributes. We will talk about robo control systems and what are the different end effectors. These end effectors play a very important role. For example, we were just discussing about a tree cutting robo. So, you change the end effector, you can use the same robo for multiple applications. So, next is application of industrial robos, then robo programming little bit, and then finally we will talk about robo accuracy and repeatability. When we talk about an industrial robo, an automatically controlled reprogrammable, this is a very important word, multi-purpose manipulator programmed in 3 or more axes, which may be either fixed in place or mobile for use in industrial automation application, is the definition for industrial robos. So, the important things are automatically controlled, reprogrammable, multi-purpose manipulator, programmable in 3 or more axes. Okay. This is very important. Why industrial robos are very important? Because robos can substitute human in hazardous work environment. Hazardous work environment means we can also take it environment which is not so conducive for human, or it can be even fatigue cycle. Okay. So, consistency and accuracy not attainable by human because of his tiredness. Then it can be reprogrammed. Robos are controlled by computers and can therefore be connected to other computer systems such that the data can be transferred quickly. From on the go communication can happen from one computer to another computer, and this can work. So, this makes industrial robo very important member in computer integrated manufacturing. When we talk about anatomy, the Robotic Industry Association has officially given the definition of industrial robo. According to the RIA, an industrial robo is a reprogrammable, multifunctional manipulator designed to move materials, parts, tools or other special devices through variable programmed motion for the performance of a variety of tasks. This is the RIA, Robotic Industry Association, given definition for industrial robots. The first one what we saw was little generic. So, it is very precisely given. So, what are the manipulator's job it is supposed to do? It is supposed to move material, parts, tools, special devices through variable programmed motion for the performance of a variety of tasks. The anatomy of a robo is also called the structure of robo. The basic components or selection in anatomy of robots are joints, manipulators, sensors and grippers. Joints are used to connect links. Two links are connected by a joint. So, this joint can give you rotational motion or linear motion. Then manipulator. Manipulator is the end effector. Depending upon the job, it changes. Then you have sensors, you also have grippers, etc. So, these are the basic components of robo. The anatomy of industrial robo deals with the assembling of outer components of a robot such as wrist, arm, body. Before jumping into robo configuration, here are some of the key facts about the robo anatomy which we should know. End effector. A hand of a robo is considered as a end effector. For example, when we talk, this is an end effector. So, this end effector, depending upon your requirements, it can do multiple operations like gripping, and then it can help in loading and unloading of parts. It can be used for eating, it can be used for washing, and so many things it can do. This is an end effector. The gripper and the tools are two significant types of end effector. Gripper, which grips it, tool is what is attached to the gripper. So, gripper and tools are the two significant type of end effectors. The grippers are used for pick and place of an object, while tools are used to carry out operation like spray painting, spot welding on a workplace. So, the end effector plays a very important role. So, the end effector has two significant types of end effector. One is for gripper and tool. What is robo joints? These are important anatomical terms which you have to understand. The joint is in an industrial robo are helpful to perform sliding and rotating movement of a component. There are only two things, one is linear, the other one is rotational. Of course, if you combine these two, you can also have helical, whatever it is, but if you can do these two operations like basic linear and rotational, so that is done by a robo joint. So, gripper, joint. And next is manipulator. The manipulator in a robo are developed by integration of links and joints. So, links, manipulator is nothing but you have a link, then a joint, a link. So, this is a link, this is a joint. It is also used in wrist to adjust the tool. Kinematics, it concerns with the assembling of robo links and joints. It is also used to illustrate the robo motion. Okay, kinematics. So, four important things are very important in anatomy: end effector, robo joint, manipulator and kinematics. This is a robo which is used for pick and place. So, it can the toughest job is picking and placing it inside a slot. If I do not put the slot, then this is not a very tough job. The resolution or the positioning accuracy is very important. So, when we talk about robo, we talk about accuracies, positional accuracy and resolutions, which in this lecture we will see what are those. This is a very challenging task. So, here is a robo which is used for pick and place. So, here is a tool, this is a tool, this is a wrist. The wrist can rotate and try to do various operations. What are the things? It can do pitch, it can do yaw, it can roll. So, roll is rotation, pitching is moving up and down, and yaw is moving left and right. So, all these things can be done by a wrist. This in combination with an elbow, where there is again a rotational joint, it can move this up and down. Then a shoulder, this can also help to move up and down. This all rests on a waist which can rotate. So, now you see how many freedoms are there: rotation about the base, then rotation about this axis, then rotation about this axis, then rotation about the wrist axis. End effector are the tools which are attached. which is supposed to do the operation depending upon the requirement. This clearly shows. So, this is a pick and place robo. When we talk about manipulator, manipulator consists of joints and links. So, joints provide relative motion. What is relative? I had a link, I have a joint, I have a link. So, this joint is going to bring a relative motion between these two fellows. So, links are rigid. This is a link. This links are rigid members between joints. So, this is a link. This is a joint. Okay. Various types of joints are linear joint and rotational joint. Each joint provides a degree of freedom, which is otherwise written as DOF. Degrees of freedom is very important. More and more degrees of freedom, it is more and more versatility the robo has to do a job. But it will make it expensive, the stability is a problem. So, all these things you have to have a trade off. Most robo possesses 5 to 6 degrees of freedom. So, generally 5 degrees of freedom is good enough to handle a complex job. Depending upon a special purpose requirement, people have even gone to 10 degrees of freedom and 12 degrees of freedom. Okay. So, generally a complex job can be done by using a 5 or a 6 axis degrees of freedom robos. So, now this clearly talks about the manipulator. Manipulator consists of joints and links, and the joints there are basically two, linear and rotational. Link is going to come in between two joints. So, each joint is going to dictate the degree of freedom. So, there are 5 to 6 degrees of freedom attached to the robo. The robo manipulator consists of two sections. One is body and arm, the other one is the wrist assembly. For positioning objects in the robo work volume. What is work volume? The space within which we can do operations. We can do operations which is specific towards, right, work volume space. So, for positioning objects in the robotic work volume, we will that is a space wherein which we can do operations. Wrist assembly for orienting the job. So, two things, please understand, two sections, body and arm. So, body, let us take an example of a human body and arm for positioning, and the wrist for orienting. So, this clearly talks about whatever we have discussed till now. So, robo manipulator, a series of joint link combination. This is called as a manipulator. So, you will have a base, link 0, link 1, link 2. Link 0 is attached at joint 1, link 1 and 2 is attached at joint 2. At the end, what we put is the end effector or end of the arm. So, when we talk about types of joints, we have two major classifications. One is linear, I said, translational, the other one is rotational. In translational, you will have two things. One is linear joint and orthogonal joints. Under rotational motion, you will try to have rotational joint, twist joints and revolving joints. So, when we want to buy a robo, the joints will be written in acronyms. So, when we write a linear joint, we call it as L, orthogonal joint we call it as O, rotational we call it as R, twist with T, revolving with V. So, this is a typical linear joint. So, link input, link output. So, here is a joint. So, this is moving along this direction. So, this is linear joint. The next one is orthogonal joint, which is perpendicular. So, you can see that orthogonal joint in link input and this is the output. So, joint motion happens like this. So, these are part of translation. Translation has two, linear joint and rotational joint. By using several of these combinations of joint, you make the body and arm structure. Then rotational, you have an input, there is a joint which is fixed and this is able to rotate. So, this is a joint and then this swings in this direction. So, this is rotational. Twisting is about this axis if it rotates. This is about this axis which is rotational, and twist is about this. So, you will have a fixed axis and then this rotates about the fixed axis. Revolving is you have this entire object, the outer link revolves around this input link. So, that is revolving. So, under rotational you will have rotational joint, twist joint and revolving joints. The robo body and arm configuration, there are 5 common body and arm configuration for the industrial robo. One is called as articulated robo, the other one is called as polar configuration, then it is SCARA robo which is selective compliance arm for robotic assembly. Very commonly used robo for pick and place is SCARA robo. This is very important. This is the acronym, you are supposed to remember this: selective compliance arm for robotic assembly. Then Cartesian coordinate robo, and then you will have delta robo. So, these are the 5 robo body and arm configuration which are commonly available. The function of a body and a arm assembly is to position an end effector in space. End effector is this, end effector in space. So, this is the basic function of this body and arm configuration. So, this is a typical articulate robo or the joint robo. So, you will have a base, and when you see that, please look at the acronym. This is twisting joint, rotational joint, rotational joint. So, if you go back, twisting joint, then rotational, rotational. So, now on all the configurations will be written like TRR. So, that means to say you have to put your understanding as twisting, rotational, rotational. So, this is twisting. So, you can see one rotation happening here, this is twisting around here, and then you will have one more rotation. So, this is an example of a articulate robo. This general configuration is like a human arm. So, what all a human arm can do, this also can do. Okay. So, see, you can do much more, but the only problem is if you have more weight in the end effector, it will topple, stability becomes a problem. So, the biggest challenge is how do you make the manipulator, how do you make the links, how are you going to activate those links. So, here is typically it is a pick and place or a gripping robo only. Okay. So, articulate robo can otherwise be called as human arm robo. Next is polar configuration, consists of a sliding arm actuated relative to the body which can rotate about both a vertical axis and horizontal axis. So, vertical axis and a horizontal axis. Okay. So, this is L or R. So, this is linear, rotational, twist. So, here vertical axis will be T and the horizontal axis will be R. So, this is called as polar configuration body arm manipulator. So, this will be written as TRL configuration. The next one what I was explaining you is SCARA robo, which is very commonly used. SCARA robo stands for selectively compliance assembly robo arm. Similar to joint robo arm, except that the vertical axis are used for shoulder and elbow joints to be compliant in horizontal direction for vertical insertion. This is the only change here as compared to the previous one. So, you will have a V joint, a R joint and a O joint. Let us see what are this V, O. Orthogonal is O, V is revolving. So, we will have V, R, O joints. So, this is orthogonal, this is rotational and this is revolve. Okay. This is a very commonly used robo for assembly purpose. So, similar to joint arm robo except that the vertical axes are used for shoulder and elbow joints to be compliant in the horizontal direction for vertical insertion task. Next is Cartesian coordinate robo. This is a Cartesian coordinate robo where we will have 3 linear joints, x axis, y axis and z axis. So, all the 3 are linear. So, the work volume what it generates will also be linear. Rectilinear robo and XYZ all are linear joints. So, this is basically used again for pick and place depending upon the sorting. The last one is called as the delta robo. Delta robo consists of 3 arms attached to a overhead base. This is a overhead base, okay, and each arm consists of 2 rotational, the first of which is powered and the second is unpowered. Very, very important. So, one is powered, the other one is unpowered. All the 3 arms are connected to a small platform. This is a platform. So, you can have a drilling machine, milling machine, or you can have a positioning device, whatever it is. All 3 arms are connected to a small platform below to which an end effector is attached. So, end effector is here. This is a delta robo. So, we saw 5 configurations which is very important, we should know: articulate robo, polar configuration robo, then selective compliance arm for robotic assembly robo, Cartesian coordinate robo and delta robo. The function of a body and arm assembly is to position an end effector in a space. Then comes the end effector. What operation you have to do is done by the end effector. Before doing it, positioning will be done by body and arm configuration. Now, let us look into the wrist assembly. Wrist assembly is attached to the end of the arm. The end effector is attached to a wrist assembly. The function of a wrist assembly is to orient the end effector. Wrist, orient the end effector. Body and arm determines the global positioning of the end effector. The orientation of the end effector is done by the wrist configuration. So, you will have 2 or 3 degrees of freedom: roll, pitch, yaw, all the 3, any 2 or only 1. So, you will have 3 degrees or 2 degrees of freedom. So, this is attached to body arm configuration, and then what is happening is this will be attached to a wrist. So, in the wrist you have pitch, this is pitch, pitch is this motion which is pitch, and then you have roll, this is roll, and then finally you have yaw. So, pitch, yaw and roll, all the 3 are rotational. Pitch is this, roll is this and yaw is this. Typical wrist assembly has 2 or 3 degrees of freedom. What is shown here is 3 degrees of freedom. You will also have 2 degrees of freedom. Just exactly pick and place, you can have 1 degree of freedom also. So, as I told you earlier, let us try to define work volume. Why is it important is you have a robo here, okay. This is a robo, and now this robo has an arm. This will try to swing in this direction. Now, when this fellow completely, when the robo completely swings, what is its working space? His working space will be something like this when you look in 2D. So, that means to say throughout the entire space he will go around and then he will start doing his operation. So much of space is called as the work volume. Of course, here I have just put some safety stock, but it is there. When you look, this is a one side view. When you look from the top, it will be something like this. Robo is here and then you have this arm. So, you will have a cylindrical work volume. So, what is a work volume? It is defined as a 3-dimensional space within which the robo can manipulate the end of its wrist. Within this space, whatever operation you want, this robo can do. So, this is known as work envelope. It is defined as a 3-dimensional space within which the robo can manipulate the end of its wrist. It is determined by number and the type of joint, range of joints and the physical size of link. All these 3 play a very important role in deciding the deciding the work volume. Okay. Size of the link, range of the joint, and then number of joints. So, uses of the joint symbol L, O, R, T, V to designate joint type used to construct a robo arm separates body and arm assembly from wrist assembly using a code dot dot. So, you can see this is for body, this is for wrist. So, now if somebody writes TRL, this is for body colon TR, it is for the wrist. So, the joint notation for 5 arm and body configuration are articulated will be TRR, polar will be TRL, SCARA will be VRO, Cartesian will be OOO, and delta will be 3 RR suffix U. So, what is the work volume? It is partially spherical, it is cylindrical SCARA, it is rectangular solid, and this is hemisphere. Partially sphere, this is hemisphere. Okay. This is a dabba, this is a cylinder. Fine. So, this is the work volume. Of course, in the work volume there will be dead spaces also. Dead spaces means those spaces which cannot be accessed by the robo. So, if you truly wanted to draw the work volume, you might have something like this. This is a space where robo is placed. So, within this space it cannot work, and this is the empty space which is considered as the work volume of the robo. Joint drive systems. See, you have now only put the joints. Now, each joint has to be activated. So, how do you activate? This can be activated by 3 types. One, it can be done through electrical way, it can be done through hydraulic way, it can be done through pneumatic way. Most commonly used one is electric drive, because its load per space whatever it is using, right, is very high. So, that means to say it can carry heavy loads as compared to that of the space. Okay. Electric motor to activate individual joints are very commonly used. It is easy to control, it occupies minimum space, it can have very high power, it is quick to response. Preferred drive system in today's robo, and it is very easy to control. You can do it today control without even wires. So, electric motors are the most commonly used drive systems. When the load or the end effector has to lift a heavy load, then electric motors will get stalled and high torque will burn the motor. We might go for hydraulics, where the gripping load is to be done very heavy. The lifting load has to be 500 kilos or 100 kilos, then we will shift from electric to hydraulic. Uses hydraulic piston and rotary vane actuators, noted for high power and lift capacity. Pneumatics for very light load and very small robos are using, is predominantly used for pick and place or for linear motion. What are the different types of sensors which are used in robos? There are 2 basic classifications in sensors. One is called as internal sensors, the other one is called as external sensors. In internal sensor, you will try to control the position and the velocity of the manipulator joint. When we talk about any rotation, we always talk about 2 items. So, this is rotation, one is positioning, the another one is velocity. These 2 are very important. These 2 are the internal category of sensor which is used for the manipulator joint. The external sensors used to coordinate the operation of the robo with other equipments in the work cell or work volume. So, it is tactile sensors which are basically touch based and force based sensor. Proximity, when an object is present within the range. Proximity and optical works almost on the same thing, but optical here you use light as a prominent sensing agent. We use machine vision. The other sensors are temperature and voltage sensors. These are the external sensors which are attached to the end effector in the robo. So, this is a tactile sensing device. A tactile sensing, because lifting an egg is a huge challenge, because egg is not circular, is not a sphere. So, it has a shape which keeps changing, and there is a radius, and here the gripper, if it is flat, you will never get a proper contact. So, what they do is they try to have a inverse of it, and then that when it touches, it has to do. When you apply lot load, the egg gets shattered. So, a tactile sensing is used today. These are tactile sensors which are attached to the end effector. These are proximity, as and when there is the current passes through or voltage passes through, it creates an electromagnetic field, and when there is a metal object which comes in that range, it quickly activates and says, oh, there is a metal object. So, then it tries to say yes or no, presence or absence of the sensors. So, these are proximity sensors. Okay, so, here is an active surface. So, when the metal surface, if it is a non-metallic object, it might not sense, and if the range is too large, it might not sense. And here, if there is a dirty environment, proximity sensor works in a big way. When we talk about optical sensors, these are sensors where we try to use an optical fiber. So, the optical fiber is used, and moment you pull or push the optical fiber, you see the strains, and then you might also try to see passing of light passing through, straining. So, temperature measuring, infrared is used. So, there are so many things. So, temperature can be measured, strains can be measured, and this is in turn attached to the external sensor of the robo. Then we have machine vision today. Machine vision works on edge detection, and the other thing is, if you have a soft material, for example rubber, and if you want to measure the dimensions of the rubber, you have to do it without touching. So, vision plays a very important role. And suppose you have a very complex texture which is on the surface, it is very difficult for measuring it through any other sensor apart from vision sensor. So, you will use camera, and there is a lens which focus on the object. So, the light hits and there is a lens. So, the camera captures the image, and this image is checked with the standard, and then it is used for various dimensions are checked, and then whichever is a defective one. So, then we put a material handling device and remove the defective sample, and the rest all is done. So, robo vision is also very important, which is in turn attached to the end effector to do the job. So, a combination of sensor examples, you can see here is a sensor wherein which you can see a cloth which is getting folded and then placed it inside. Pick and place is also there, and it is also getting folded. So, here we use a combination of sensors. First we have to use a tactile, then we have to use vision, then we have to use image, and then finally we have to do this operation. Though it is in manual way, it is very easy, but asking a robot to fold a cloth is a big challenge, and a sensor to find out weight, color, texture, and then decide what is the operation to do. So, this is a combination of several sensors which is used as an example. The next one is the robo control systems. Till now what we saw the body and arm configuration, then we saw different types of manipulators, and then in the manipulator we saw different types of sensors, and now we will try to, and in sensors we saw two, which is internal sensor and then external sensor, and now we will move into control systems. The control systems, limited sequence control is pick and place operation using mechanical stop to set positions. Playback with point to point control is records work cycle as a sequence of points, then plays back the sequence during the program execution. For example, this is assume that there is a blind man, the blind man is held by his stick and he is walked from A position to B position. He registers the number of steps, and then when he has to repeat the same thing, he will do it the next day by just doing the same counting of steps, moving left and right and reaching towards the destination. So, that is nothing but playback with point to point. He only is worried about the line in which he has to move. He is not worried about whether a zigzag motion little bit, but he is only worried about start point and end point. Playback with continuous path, greater memory capacity and or interpolation capacity to execute a path. Like in CNC machine, this is nothing but G01 command, this is nothing but G02 and G03 command. start point, end point, interpolation, and several other details are to be loaded. So, it is playback with continuous, and the last one is intelligent control, exhibits behavior that makes it seems intelligent, responding to sensor inputs, makes decision, communicates with the human, and then he tries to control. Today all the driverless vehicles are thought of in intelligent control system. So, these are the 4 different types of control system: limited sequence, playback with point to point, playback with continuous, and intelligent control systems. When we talk about robo control systems, input output, so there is a program store, and then there is a executive processor, and then there is a computational processor. So, these are the joints which are linked to it. This is a typical hierarchical structure of a robo microcontroller used. So, we will have a program which is stored, then we will have a computational processor. This is the executive processor. So, input output is given, joints are given their values, if it is rotational, linear, angle, or displacement is given. So, accordingly the joints work. So, this is a hierarchical structure of a robo microcontroller system. The end effectors, a special tool for the robo that enables it to perform a specific task. There are 2 types of end effector, one is called a gripper, the other one is a tool. A gripper to grasp and manipulate an object, where tool is to perform a task. So, this is a gripper. So, you can see a 2-finger gripper, you can have both the fingers moving, or you can have one finger fixed and the other finger moving. Both are used for gripping action. The 2-finger mechanical gripper for grasping rotational part is there in a gripper. So, you can see here these are all rotational joints, this is a rotational joint which is given, and you just have to put a motor and activate it. The advances in mechanical gripper are, there are dual grippers, interchangeable fingers. So, that means to say you can make a finger size larger, smaller, round, box, prismatic like, helical like, whatever it is. Then sensor feedback to sense presence of an object, to apply a specific force on an object. So, these are some of the advancement. Suppose if the object itself is not there, they have an optical sensor, it detects no object there, it does not work. The second thing is, it tries to apply a load, and if it feels that there is a slipping happening by the object, between the object and the gripper, then it will try to apply a specific force or increase the force to have a proper holding. So, multiple finger gripping is also there, and standard gripper products to reduce the amount of custom design requirements. All these things are recent advancements which are happening in robo, so that they make the handling and the processing much more easier and faster. So, applications, material handling applications we have discussed, pick and place and uploading, then processing, spot welding, spray coating, water jet cutting, laser jet cutting, heat treatment, etc., etc., assembly and inspection. These are the 3 areas where industrial robo plays a very important role. So, this is a typical pick and place robo, you can see, and then these are robos where there is welding which is happening, and these welding you can see there, the object is twisted, moved up and down, and then you can see the gun which is attached to a gripper, robo gripper, which moves on a complicated profile to get the welding done, and simultaneously 2 weldings are done, and the job is done without any much of error. So, robotic arc welding cell is now a common thing which is coming up, which is exhaustively used in car industry. The robo performs arc welding / spot welding if you want. So, arc welding at one welding fixture, while the work changes part at the other. So, it is typically like your CNC machines. So, one place the new job is getting loaded, the other place the operation is going on. By the time the operation is going on, the next job is ready. So, moment it is ready, this swaps, this goes inside and this fellow comes outside, and a arc welding process continues. Here it can be in a straight line, it can be in a contour, you can have multiple axes either to the robo arm or to the workpiece to make complicated welding joints easy. So, moment you say arc welding, you can fix a laser, you can fix a water jet to get complicated profiles. Today we have 5-axis water jet cutting machines, 5-axis laser welding machines. So, the robo application characteristics are General characteristics of industrial robo situation that promote the use of an industrial robo. Wherever there is a hazardous environment, try to use robo. Wherever there is a repetitive task, use robo. Wherever there is a difficulty in handling by human, use robo. So, you do a multiple shift operation, a robo can do infrequent changeover. So, where the changeover is not very fast, one full shift, one job is done or a set of jobs are done, then we can use robo. Part positioning and orientation are established in the work cell. So, these are the characteristics for robo application. When we talk about programming, robo programming is also a very important thing. So, if you can teach by holding by hand, it is by teach pendant, or holding by hand, it is a primitive technique. Today what has happened, we have now started working on obstructional deduction and finding out the shortest paths to reach from the source to the target. So, robo programming has come up in a big way. A robo programming can be defined as a path in space to be followed by a manipulator combined with a peripheral action that supports the work cycle. So, you will have opening and closing a gripper, you will have performing logical decision making and communicating with other pieces of equipment in the work cell. These are some of the examples of peripheral actions. So, robo programming is coming up, and there are several languages which are developed today in which you can start writing the robo programming. And like CNC, you can also use G codes for writing the robo programming. So, types of programming which I just discussed: lead through programming, robo programming through language, simultaneous and offline programming. Lead through programming, a work cycle is taught to a robo by moving the manipulator through the required motion cycle and simultaneously entering the program into a controller memory for later playback. So, it is just like holding a blind man walking through, having a teach pendant doing that. So, lead through programming is that. Next is robo programming language. We use a textual programming language and enter the commands to tell the movement of the robo within the work volume. Next, simulation and offline programming. The programming is prepared at a remote computer terminal and downloaded to the robo controller for execution without need for lead through method. So, this is an interesting thing. Lead through programming, again there are powered lead through and manual lead through. Commonly it is point to point. Manual lead through is continuous. This is very important. Uses a teach pendant to move joints to desired position and record the position. So, it might move in a bang bang position, start stop. So, it will go very fast and the path is immaterial. So, human program physically moves the manipulator through the motion cycle, records the cycle into the memory, that is manual lead through. So, you have powered lead through and manual lead through. So, the advantage is it can easily be learned by the shop floor man. A logical way of teaching a robo does not require knowledge on computer programming. It is something like a semi-skilled labor can teach. So, here the disadvantages are the downtime. Regular production must be stopped to program the robo, limited programming logical capabilities, not readily compatible with the modern computer based technologies is lead through programming. So, once you have done through lead through, if you want to edit that lead through programming, it is very difficult. So, that is why we use simulation and offline programming. Textual programming takes the opportunity to perform following functions that lead through programming cannot readily do: enhance sensors capability, improve output capability to control external equipments. Program logic not provided by lead through methods will be done by robo programming. Computational and data processing similar to computer programming languages can be done by robo programming language and communicates with other control systems. So, when we talk about a robo, there are two types of coordinate system. One is called as world coordinate system, the other one is called as user coordinate system. This is the world coordinate system with 0 0, and at every joint you will have a user coordinate system, and you will, for a tool also you will have a user coordinate system. Now, every time when we write a program or when we try to do an analysis, we should make sure that the axes of the world coordinate system and the user coordinate system are the same. Otherwise, we have to transfer or translate these references in such a way with respect to the world coordinate system and then execute the program. So, what happens is this will try to give you a proper control over each of these joints to execute the job. So, origin and axis of the robo manipulator are defined relative to the robo base. So, origin and axis of a robo manipulator are defined relative to the robo base. So, world coordinate system is very important. At each joints you should be able to put a reference coordinate system, find out the XYZ axis and then try to put them properly, then start writing a program. So, in fact, in the forward kinematics what we do, we try to bring all the translations, rotation about the axes and then we try to map it with world coordinate system and then execute the movement. So, there is a world coordinate system, there is a tool coordinate system. This is the tool coordinate system. So, you see here this is the Z axis, X axis, work axis, right hand coordinate system is used. So, the world coordinate axis, this is the Z axis and these are the other two axes. Alignment of the axis system is defined relative to the orientation of a wrist face plate to which the end effector is attached. This is the wrist face plate. So, moves are relative to axis systems defined by a tool orientation. So, this is the motion programming commands. So, we will say move P1. So, here P1 used through lead through manipulator, then moves P1, then D move 4, 125, these are the coordinates, approach P1 which is 40 millimeter, depart from 40 millimeter, define path 1, 2, 3, path P1, P2, P3. So, P1, P2, P3 will be defined earlier, move path 1, 2, 3 with a speed of 75. So, this is a motion programming which is used, lead through is 1, then it is motion based. So, then interlocks and sensor commands are given. So, wait 20 seconds or 20 milliseconds, signal 10 is on, signal off, then react, safety, stop, yes, no. The gripper commands can be basic open, close, or it can be close and wait or close with a load. So, it will be 25 millimeter, close at 2 newtons. The simulation and offline programming. In conventional usage, robo programming language still requires some lost production time in order to define points in the workspace that are referred in the programming. They therefore involve online and offline programming. Completely you do a robo path finding and then you make a layout and then allow a robo to move in that layout and then find out where all the obstructions are there, how can it jump over the obstacles or detour from the obstacles and reach the target. So, now this is simulation is done and offline programming is done. So, this tries to give a better control over the situation. So, in lead through it was not talking about the sensors and other things. In motion control we were talking about sensors and its function attached with the lead through. Now, simulation and offline is the next advanced one. The advantage of true offline programming is that the program can be prepared beforehand and downloaded to the controller with no loss of production time. The graphical simulation is used to construct a 3D model of a robo cell so that you can plan your operations. The last part of the robo discussion is we have to understand robo terminology called robo accuracy and repeatability. There are 3 terms which are defined in as far as robo is concerned, just which is very similar to that of a numerical control system: control resolution, accuracy and repeatability. Repeatability is nothing but the capability to position the wrist at a previously taught point in the workspace is repeatable. I repeatedly do a task, what is the accuracy? So, repeatedly do or repeatedly go to the same place. So, capability to position the wrist at a previously taught point in the workspace is repeatability. Accuracy is the capability to position a robo wrist at a desired location in the workspace given the limits of the robo control resolution. Okay. Accuracy is nothing but the capability to position the robo's wrist at a desired location in the workspace given the limits of the robo control resolution. So, the control resolution is capability of a robo positioning system to divide the motion range of each joint into closely spaced points is resolution. If you talk about a computer, pixel is a resolution. The least count, the capability of a robo positioning system to divide the motion range of each joint into closely spaced point is called as resolution. So, these are three important terminologies which are very similar to that of numerical control. Control resolution, accuracy, repeatability. Repeatedly I go to a place, that is repeatability. How close I go to the set target is resolution. Accuracy, capability to position a robo wrist at a desired location in the workspace given the limits of the robotic control system. So, to summarize what all we covered in this, what is your robo anatomy, what is your robotic related attributes, what is degree of freedom, control systems, end effectors different type, application of industrial robo programming and accuracy and repeatability. These are the topics which we were covered in this lecture. So, I would like to give you a small assignment before I conclude. So, this is an assignment. You do not have to give it to me or submit it. Okay. So, try to, let us play a small thing and try to understand resolution and accuracy we will try to see. First, close your eyes. First step. Second step, what you do is you try to keep a glass, empty glass in front of you, okay, and start filling the glass with liquid. Try to assess the level of filling both by inserting your finger inside the tumbler, inside the glass, and listening to the sound while filling. You first try to do this and assess it. Now, you see how difficult it is, and after assessing it, right, try to take another empty glass and fill without touching the glass. So, now touching the glass. Now, you try to see one more time what you have assessed, and when you stop pouring it, can you assess it. So, this is a very difficult task to do. By practice, yes, it can come. The next thing is try to understand the concept of repeatability and accuracy by shooting a ball into a basket. Please do this. So, then you will know, you as a system, what is your system's repeatability, accuracy, and these 2 points you plus do it. Do these 2 experiments, do not have to submit to me. What we are trying to understand is how teach, lead, through will be used, and try to understand the concept of repeatability and accuracy as far as a system is concerned. Thank you.